Now that we know how to solve quadratic equations, in lesson 19 we're going to revisit lessons on transformation of the graph. So we're going to start with our parent function. For a quadratic, that would be x squared. And I have three functions right here. The first one being the parent function. And what I want to know is, I want to know how much you can remember from our transformation lessons. So let's look at g of x. How did the parent function change? So yeah, I know that we added 3, but how did the graph change? How did it move? How did it translate? And don't worry so much as to the words that you use, but be able to describe. Now we know that if this would be in vertex form, we know that that's also the y value, the 3. And that should indicate for g of x and h of x, the y value is -7, but that should indicate that there's something happening with the y-axis. And so because the adding or subtracting of a value happened after we're squaring our x's, you may remember that we used to say if it happens inside the parentheses or outside the parentheses, it's going to do something different. And so we're going to revisit that and thinking about how this is changing in the graph. And of course, if you remember correctly, this would be a graph for g of x that moves up the y-axis 3 units, and h of x is going to move down the y-axis 7 units. So it's a vertical change. It's moving up and down, and that's what's happening here. And so we used to say inside the parentheses and outside the parentheses, and now I'm going to use something different. I'm going to say before we squared or after we squared. And so basically, if the addition or subtraction happens after we square the x, then that change is going to be vertical, meaning it's going to move either up or down. Now, let's bring this all back together. Now, how you can watch these videos is you can try to do this at this point. You're not learning anything new, we're just reviewing. So try to do these on your own. Pause the video at any moment and try to answer it. We have 4 different graphs, and we have to have a matching exercise here. We have equations in the center column, and we have descriptions in the very right-hand column. We have to match the graph with the equation and description. So at any point, just go ahead and pause the video and try to do this on your own. Let's start with the first graph. I'm going to go ahead and move along, but know that you can move the video back and forth and however you would like. Starting with the first equation, we have our vertex there. I know the numbers are really hard to see, but your scale is only going by 1. So my maximum in this case would be a 3 and -2. And I know because of my vertex form that the opposite is going to be in the x value inside the parentheses or before you square it. And then after you square it, that value is going to be your y value of your vertex. So my equation for that would be E3. Now I also know, because this is a reflection on the x-axis, that I should have a negative coefficient, and that's precisely what we see there as well. We have that negative that is right outside your parentheses x -3. All right, so moving on, when I look at what description would be best for this, I am thinking that D2 might be the best description for this because the graph of the function does not have an x-intercept. Now I'm going to move on to my next graph. Again, you can pause at any time. Here's a vertex, 3, 0, and it is a minimum. Now, I'm going to say that the equation is going to be E1 because I'm adding 0 to this, so my y value is going to be 0, and my x value, it's already in vertex form, is going to be a +3. And when I think about what the parent function and how it changed, it actually moved 3 units to the right. So it cannot be the description for D1 because D1 says, oh, it's moving left 2 units. That's not it. So it cannot be D3 either. So the only possible description here would be D4, meaning it only has one x-intercept, which is your vertex. Your minimum is also your only x-intercept. All right, so now I'm going to move on to And I'm actually going to write this down here. It's better than putting arrows and circles so that we know what choice is already taken. I'm going to move to the third and fourth graph. Again, if you want to try these on your own, you can pause the video now and try to see which equation and which description match these graphs. So for h of x, my vertex is 2, -3. And I know that my opposite x cannot be E2, and that's why my E4 is the only possible choice there for -2, because that's the opposite. Remember, when you have it in vertex form, your x value is going to be the opposite, and then -3 is the y value. And then, of course, the description that matches this would be, let's see, for my parent function, I am actually moving down 1, 2, 3, down, and I'm moving to the right, so I'm not moving to the left, so it cannot be D1, so that means that D3 is my answer for this particular equation. So there I'm drawing the parent function, but I already know that the y-intercept and x are both positive, so I'm not moving to the left. All right, let's go ahead and move on to the next one, which is y equals px. When I'm looking at my vertex here, there's only one choice left really, but I also want to make sure that I didn't make any mistakes. So my vertex is -2, -3. And of course, for the equation of E2, the opposite of +2 is -2, and the -3 is on the outside. So that, of course, is my equation. And then looking at how my parent function changed, it moved down 1, 2, 3, and to the left 2 units. So that's why that's the description. All right, if you didn't try those before on your own, this is the time for you to do it on your own. Pause the video and answer these questions. So I'm going to trust that you did this already, and the parent function x squared, that should have been a given. You should have been able to get that. How is this translated graph relate to the graph of the parent function? Basically, how did it change? Well, it moved 1, 2, 3, 4 units to the right. And so we know that when this horizontal move happens, we're talking about the x-axis moving. We know that in the vertex form, the x value of your vertex is going to be before you square it, or inside the parentheses, however you want to say it. So that means that my parent function is going to be x minus 4, and then I'm going to square it. I'm not moving up or down, so there would be nothing to add or subtract after that. So this would be it. This is the formula for the translated graph.